चल ठीक है this one M19 ठीक है 1 2. So let's start in reverse order, starting with the first one. This question. Carboxylic acids may be prepared from alcohols, nitriles, and esters. Which statements are correct? Both primary and secondary alcohols can be oxidized to carboxylic acid. Is that true?
False.
No.
You can't make a carboxylic acid using secondary alcohols. Carboxylic acids can be made from nitriles by hydrolysis.
Yes.
That one is true. Nitriles, they turn into carboxylic acids. Last one is ethyl propanoate is going to give you propanoic acid when reacted with hydrochloric acid.
Yes.
Okay, that's because the ester will break down. The ethyl part is from alcohol, that's ethanol, and the propanoate part is from the carboxylic acid that's going to make propanoic acid. So that is also correct. Compounds listed are reacted with HCN. Which compounds produce a molecule with a chiral center? So butanol is this thing. What will happen when it reacts with HCN? That's nucleophilic. He gets this one. It's nucleophilic addition. And a cyanohydrin would be formed. That the carbon over here will have an OH and a CN getting attached to it. So if you go back, this will become OH and this one will become CN. That's how HCN gets added, nucleophilic addition. Is this chiral?
Yes.
Okay, that one is chiral. What about butanone? It's a ketone.
Sorry, screen is stuck.
No.
ठीक है. The screen stuck है कि नहीं है?
Sir?
This yes.
Yeah. On the chart.
Is it? It's not stuck at my end. देख लेता हूँ just a second.
Okay, now I can see the paper. Yeah.
So butanone. That's going to give you again. CN gets attached and it becomes OH. It turns into a cyanohydrin, and you get this molecule, and that is also chiral, right?
Yep.
So now the last one, pentanone. That's 5 carbon atoms. Again, it's a carbonyl group. CN gets added, nucleophilic addition. Okay, so that will not be chiral, right?
Sir, pent-2-on the second carbon.
Sorry. In that case, will that be chiral?
Yes.
Okay, in that case, you had a double bond to O, it will become OH, and this one will become CN, and that carbon is going to be chiral. Okay, that one is chiral. As the next one, we've got chlorine atoms in the upper atmosphere. This is how they're reacting with the ozone. Which statement? Chlorine atoms act as catalysts. Is that true?
Yes.
Okay, they remain unchanged during the reaction, so that they're acting as a catalyst. The chlorine atoms are free radicals.
Yes.
A chlorine atom, remember, is by default a free radical because it has an odd number of electrons. Anything that has an odd number of electrons is by default is a free radical. The chlorine atoms are formed by the heterolytic fission of a covalent bond in chlorofluorocarbons. Is that true?
Yes. No.
No.
Okay, that part is true. Okay? The CFC breaks down, right? But it's not like if I have a CFC, like a chlorofluorocarbon, one of the bonds will break down, but it will break down homolytically, not heterolytically. Homolytically means that the electrons would be equally shared. One electron would go back to Cl, one electron would go back to this carbon and two free radicals would be formed. So it's going to be homolytic fission, not heterolytic. I said this one, which statement about cholesterol are correct? The molecule contains a secondary alcohol group. True or false? Does it have a secondary alcohol group?
It does.
Okay, so this one is two carbon chains. The molecule contains two pi bonds.
No.
Okay, that's wrong. Only the double bond has a pi bond, and there's just one of them. All carbon atoms in the four rings lie in the same plane. In four rings, do they lie in the same plane?
No.
Okay, they don't. Okay, for the same plane, it should have at least, trigonal planar is when it has at least a double bond that's fan-shaped, completely flat. Otherwise, these carbon atoms are tetrahedral. So what type of bonding are present in ammonium carbonate? Does it have an ionic bond?
Yes.
Okay, so it does have an ionic bond. Ammonium is +1, carbonate is -2. Does it have covalent bonds?
Yes, it does.
Okay, what about coordinate bonds?
Yes,
Yes.
it does.
Okay. The coordinate bond, ammonium has covalent bonds. There's one bond that is a coordinate bond where the H+1 gets attached to it. Carbonate is also covalent bonds. Non-metals covalent bonds. But the overall charge on this molecule is a -2. Which statements about ceramics are correct? So they're good electrical conductors, strong materials, and have high melting points. Which one is wrong?
The first one.
First.
The first one. Remember, they just have three properties: strong materials, high melting points, and electrical insulators. And there are three ceramic materials. The popular ones: MgO, sand, SiO2. You make clear ones out of, and Al2O3. So platinum and palladium can be used as catalyst. This is about catalytic converter. The reactions are faster when platinum is the catalyst than they are when palladium is the catalyst. Which state when platinum acts as a heterogeneous catalyst? Is that true?
Yes.
It has a different state. The reactants are your waste gases, carbon monoxide, nitrogen oxides, and unburned hydrocarbons. Whereas the catalyst is a solid. Just a second. So for the next one, the palladium catalyzed reaction have higher activation energy than the platinum catalyzed reaction.
True.
Yes. Yes.
The reactions are faster when platinum is the catalyst. So that means it has a lower activation energy, right? So this statement is correct. As the platinum catalyzed reactions are more exothermic than the palladium catalyzed reaction.
No.
True or false?
False.
So remember, catalyst does nothing to the enthalpy change. The enthalpy change remains the same.
It just lower the activation energy.
The enthalpy change, if this is the overall energy change of the reaction, it remains exactly the same, except that the initial energy that is needed at the start, that would be lower. So the enthalpy change never changes when you add a catalyst. In which reaction is the underlying element or compound reduced? First one, is it reduced? And what is the oxidation state if it is reduced?
It is reduced.
So what is the oxidation state over here? That's
+1.
this is +1, and over there it is -1. So 1 is correct. What about N? Is it reduced or not? What is the oxidation state over here for N?
3 minus.
+3.
Oh,
-3.
-3,
3 minus.
sorry.
Age is +1. What is the oxidation state of N on the other side?
4 minus.
This is Still -3.
Minus
Lithium is group 1, that's +1. Nitrogen is unknown, that's X. And there are 2 hydrogens, that's +1 times 2. And the overall thing is neutral, so it should add up to be equal to 0. And if you solve for this, it still comes out to be -3. So N is still -3. So that means nothing happens to N, although it is a redox reaction. The element that is reduced is, I think, H goes from +1 to 0. I said, what about over here? Is this getting reduced? You have an alcohol, and over here you have an aldehyde.
Oxidation.
Oxidized.
Yeah, that's oxidized, so that's also wrong. So the second and third statements are wrong. I say, in which pair do both species have the same number of unpaired electrons in p orbitals? How many unpaired electrons in p orbitals does oxygen have?
2.
Oxygen is 8 electrons, right? So it's 1s2, 2s2. And what else? It's that's 2p4.
Yep.
Okay, so it is 2, 2, 1, 1, right? So it's got 2. What about Cl plus 1? So we should do this without writing electronic configuration. It's going to take too much time. Oxygen is in group 6. So it should have been S2N P4. Cl is group 7. What is the electronic configuration of something that's in group 7 for the outer shell?
P5. P5.
Okay, that's S2P5. You don't have to write the whole electron. And since it's +1, so it's also going to be P4. So that means they both have identical outer shell electronic configurations. So everything remains identical, right? What about fluorine? What is the electronic configuration of fluorine group 7? That's
S2P4.
It should have been S2P5, but it's at the moment S2P4 because of the +1 charge. Gallium, I think, is below aluminium. That's
P1.
which group is? So that's going to be S2P1, right?
Yep.
But it's going to be S2P2 because gallium is -1, right? So do they have the same number of unpaired p orbitals? I mean, this is S2P4, that's S2P4.
No.
Yes.
They actually do have the same number of unpaired p orbitals because P4 means this thing, 2 unpaired, right? So P4 means, because one of them would be completely full, right? If you have P4. So that means it's got 2 unpaired. P2 by default, if you just have 2 electrons in the P, that's going to be one over here, the other one is empty, right? So it's going to be 2 unpaired as well. So both of them have the same number of unpaired p orbitals. Okay, clear?
Sir,
Yes.
won't there be a difference because S2P4 there's one like filled p orbital, but in gallium there isn't.
No, but they weren't talking about how many are filled or how many are empty. They're talking about how many of the electrons are unpaired. Like unpaired electrons in p orbitals.
Yeah, there's 2.
So if it's P4, there are 2 orbitals that are unpaired, 2 electrons that are unpaired, right? In P4.
Yeah.
We don't care about which ones are filled. They're talking about the unpaired electrons only. And if you have S2P2, what is S2P2? That's PX, PY, PZ, and that's 1, 1, and 0. So you still have 2 electrons that are unpaired, right?
Right. Okay.
So basically you have the same number of unpaired. So 2 is correct.
Unpaired, okay.
I said, what is nitrogen group 5? What is the electronic configuration of nitrogen group 5? That's S2N?
P3.
Yeah, that's going to be S2 and P3. So P3 means 3 unpaired. PX, PY, PZ, each one having 1 electron. Krypton is a noble gas. Noble gas should be S2P6. But since it's 3+, it would be S2P3. So it's the same electronic configuration. So that is also correct. So all 3 are going to be considered correct. Okay, clear?
Yes.
Sir,
Yes.
can you kindly explain this method in a bit detail because I'm not familiar with this?
It's just that writing electronic configuration takes a very long time. Like, I mean, you can write the whole electronic configuration, but if you have to write 6 of them, like krypton is a big atom. Like, I think it has 36 electrons. Anyways, writing electronic configuration takes some time. The easier method is, okay, any element that's in group 1 is going to end with S1, whatever the electronic configuration, the outer shell would be S1. Any element that's in group 2, that's going to be S2. Any element that's in group 13, that's going to be S2P1, and so on. If something is in group 14, its outer shell would be S2 and P2. But if silicon has 14 electrons, right? So if I write the electronic configuration, it's going to be 1s2, 2s2, 2p6, and then it's going to be 3s2 and 3p2. So the outer electronic configuration is exactly the same. Is the idea clear?
Yes, sir.
15 would be S2P3, 16 would be S2P4, 17 would be S2P5, and noble gases would be S2P6. If you take any krypton's electronic configuration, it just saves you a lot of time. It's if there is. So the outermost is 4s2 and 4p6. You don't have to write the whole thing. Is that clear? So इस पे आ जाते हैं. We've as a previous one. So now there's an just hold on 1 second. So now this next one is, you've got an experiment, and there is as you've got an experiment, there's 10 cm3 of an organic compound J in the gaseous state is reacted with an excess of oxygen, steam, 20 cm3 of carbon dioxide, and 5 cm3 of nitrogen are the only products. All gases were measured at the same temperature and pressure. As a first thing, remember, for gases, mole ratio and volume ratio is exactly the same. So if there's a 10 cm3 of an organic compound, we don't know what that organic compound is. That's J. So it has a bunch of carbon, it has carbon, hydrogen, and nitrogen. We know all 3 are present. We don't know what the quantity is. So I'm not sure how many carbons, how many hydrogens, how many nitrogens. And it's reacted and it produces 20 cm3 of carbon dioxide. So 10 cm3 produces 20 cm3. So what is the mole ratio? That's 1:2, right? So one molecule produces 2 carbon dioxide. That indicates that the mole ratio would be, carbon over here would be 2. That's the only way that one molecule produces 2 carbon dioxide. Is that clear? And you also have 5 cm3 of nitrogen being produced. So N2, 5 cm3 of air. So if you have, so this is 1:half. Like if you have one molecule, 10:5 is basically 1:half. So the ratio, remember this, I'm going to repeat this. For gases, the volume ratio and the mole ratio is exactly the same. You don't have to make the whole complete equation. I'm just making a partial equation. 10 cm3 produces 20 cm3 of carbon dioxide, 5 cm3 of nitrogen. So mole ratio would be exactly the same. 1:2 half. 10:20:5 is 1:2 half. So if half N2 is getting produced, that means how many nitrogens would there be? There would be just one of them. I mean, that's why half N2 are getting produced. So it's going to be C2 and N1, and I don't think we have any information. Do we have any information about hydrogen? Just one. So is there any information given about that we can use?
No.
I don't think there is any information. Just hold on one second. So there's in this question, there's no information that's given. So you better consult with the marking scheme. The first one is definitely wrong. You got 2 carbons and 1 nitrogen. That's definitely true. We don't have any information. So
MSSC.
C, right?
Yeah.
But is there any information that's given about hydrogen? I'm just 10 cm3.
I think
there's no information that's given about hydrogen.
It
right?
says steam. The only thing it says is steam.
They didn't give the volume, so we can't really predict how much steam would be produced, right? If they had given us. But is this clear? This thing?
Yes.
Okay. Just a second. Acha, पिछले पे चलें. Number 30. So they didn't give any information, but this one, infrared spectrum shows a strong peak at 1710. What is that? And broad peak, what is that?
1710, it's C double bond O.
You got a C double bond O and a broad peak, that's an OH. And it's an OH that belongs to a carboxylic acid. So it's going to be C, right? Is that clear?
Yes.
So previous one, you've got 1 mole of each of the 4 compounds is reacted separately with an excess of sodium and excess of sodium carbonate. Which compound produces the same volume of gas with each of the 2 reagents? Starting with the first one, will it react with sodium?
Yes.
Yes.
Do you remember alcohols they do react with? Alcohols over here, they do react with sodium. But alcohols don't react with sodium carbonate. They have no reaction whatsoever. So with sodium, they're definitely going to produce hydrogen gas. Okay, the alcohol will react, but no reaction with sodium carbonate. So the first one is wrong. The second one is an alcohol and a carboxylic acid. Now, in this case, with sodium, both of them would react. This would react. It would release hydrogen gas. This one would also, the alcohol would also react with sodium. So with sodium, both of them will react. But with sodium carbonate, it's only, so how much gas is produced in this case? That's 1 mole of H2 gas, right? Because 2 hydrogens are going to get displaced. There's going to be sodium over here and sodium over here as well. So 2 hydrogens will be displaced, so 1 mole of H2 gas would be produced. And in the next one, you've got sodium carbonate. When you do the same reaction with sodium carbonate, sodium is going to do the same thing over here. And how much carbon dioxide would be produced? Sodium carbonate, remember, only reacts with. So we can make a balanced equation for this one. This molecule over here is CH3. The first carbon is CH3, then you have CHOH. Then you've got the carboxylic acid group. And if I react it with sodium carbonate, so if I react it with sodium carbonate, the salt that's going to be produced.
Why OH twice?
So it's not OH twice, it's just once. And the salt, the alcohol part will not react. So it's going to be CHOH. And CO -1 and Na +1, that's the salt that's going to be produced, and water and carbon dioxide. Anyway, so if I balance this, how would I balance this? There would be 2 moles of this, 2 moles of this, and 1 carbon dioxide. Is this equation looking balanced now? Because there are 2 sodiums, 2 salts, 2 sodiums over here. So you would need 2 moles of this. The 2 hydrogens that are displaced will form water. They'll react with the oxygen and the carbon dioxide molecule will be produced. So how much gas is being produced? The ratio is 2:1 now. So 1 mole is going to produce, how much? It's going to produce 0.5 moles of carbon dioxide. So it's not going to be the same. Is that clear? So I'm just going to repeat this again. The reason I'm writing the whole equation is because they weren't even interested in the identity of the gases. They were just interested in the volume of the gas. So I need to make sure that the volume of the gas is correct. So if sodium, only sodium reacts, sodium will react with both OH groups. So 2 hydrogens are going to get displaced. And when 2 hydrogens are displaced, there would be 1 mole of H2 gas that will be produced. But when you react the same molecule with sodium carbonate, in that case, only the carboxylic acid end will react. And when it reacts, it produces the salt at this side. And if you balance it, you would realize that 1 mole will produce just 0.5 moles. So the amount of gas is not coming out to be the same. Is this clear?
Yes, sir.
Okay, so the correct answer is going to be, it's probably going to be D, that it's a double carboxylic acid. It's got carboxylic acid on this side and it's got carboxylic acid on this side as well. So sodium will react with both. Remember, carboxylic acids react with both things, sodium and sodium carbonate. Now, in this case, both hydrogens are going to get displaced. Salt will be produced at both ends. So it's going to be Na plus 1, and on the other side as well, you will have a salt and H2 gas will be produced, and there's going to be 2 Na and exactly 1 mole of H2 gas will be produced. And if I do the same reaction with carbonate, and again, I'm interested in the volume, so which is why I'm writing the whole equation. If I reacted with sodium carbonate, I'm going to get the same salt. And I'll have Na plus 1 and CO minus 1, Na plus 1, plus H2O plus CO2. So this kind of looks balanced. In this case, 1 mole of H2 gas is produced. And in this case, 1 mole of CO2 is produced. So that is the correct option. Okay, my only concern was that there were 2 different reactions. So I needed to make sure that we have a balanced equation so that we can figure out, are the moles of gas exactly the same or not? Okay, so D is the answer. Is this clear?
Sir, I have a question.
Yes, sir.
Yes.
सर आपने कहा था कि जो Na वो है हमारे पास सोडियम कार्बोनेट जो है वो रिएक्ट नहीं करेगा अल्कोहल के साथ, सर वो क्यों नहीं करेगा?
No, it doesn't, because alcohols are very alcohols are extremely bad acids. Okay, they don't ionize a lot. Remember this for alcohols, that any alcohol, you'll learn about the reasoning in A2, okay, about why alcohols are bad acids, but alcohols have terrible ionization. It's even less than water. Okay, so this thing, alcohols are not interested in producing H plus 1 ions. So which is why alcohols don't have any reaction with bases. Like if I have an alcohol and I react it with NaOH, so there's not going to be any reaction because the alcohol is not going to give its H plus 1 to the OH ions to form water. Okay, that's how water is formed in a neutralization reaction, that the acid produces a proton, it produces an H plus 1. And the base on the other side, which is OH minus 1, accepts that H plus 1. So that's an acid-base reaction. You will not have this acid-base reaction because alcohols are really bad acids. Okay, the only acidic reactions that they have is the one with sodium. That's not even an acid-base reaction. That's a redox reaction. That sodium is so reactive that what happens is that if I have an alcohol, sodium really likes to lose electrons. That's a redox reaction. Metal plus acid produces salt and hydrogen gas. So what sodium does is this H, sodium gives electrons to this H. This H plus 1 turns into H2 gas. It accepts those electrons and sodium turns into an ion. It becomes CH3, CH2, O minus 1 and Na plus 1. So it's a redox reaction. So that's the only redox reaction that happens with alcohols. Okay? So remember this thing, remember this difference. TK, you don't have to learn the reasoning right now. TK, that will be part of A2. But remember, and there was one question about this as well. TK, I'm just going to repeat that question. And that was, they did ask you in one of the questions. And that was about Bronsted-Lowry conjugate acids and bases. In that, what they asked was, okay, what is this? This one is a very strong conjugate base. The reason why alcohols don't ionize is that this thing has such a strong negative charge, it does not allow the H+1 to leave. It quickly accepts that H+1 and turns back into an alcohol. The O and H bond is very, very strong. So it's a very strong conjugate base. It does not allow the H+1 to ionize. Okay, is this part clear? You clear?
Yes, sir.
Okay, so just remember, there was one MCQ, somebody sent me that MCQ, and that was that in that MCQ, they were asking about is this it's a very strong conjugate base, this one. Weak acids always have very strong conjugate base, which is why the H+1 is never able to leave the molecule. The H+1 quickly, strongly gets attracted back. So about alcohols, just remember that they only have one reaction, which is with sodium, no reaction with bases. Alcohol does not like to lose H+1. Carboxylic acids, they do like to lose H+1. They have reactions with everything, with metals, with bases, with weak bases like sodium carbonate as well, and with weak bases like ammonia as well. So moving on, this one, you've got X is heated with Cr2O7, a color change from orange to green is observed. 2 tests are carried out on the organic product of the reaction. Tollens reagent, no change. What does that mean?
It's not aldehyde.
Okay, so it's definitely not aldehyde. And 2,4-DNPH, you get an orange precipitate. So it is what?
Ketone.
Below.
See, that's a ketone. So what could be compound X? What is compound X then?
A.
It's not A. It's a D. It's a secondary alcohol, because remember, he's talking about compound X. You can make sure, I mean, these are just slightly tricky questions. Keep your eyes open for this. They're asking about compound X. Once it's oxidized, then these tests are carried out. So when you oxidize this thing turns into ketone, and that ketone has this particular test. So basically, what X is basically D. You clear?
Yeah.
Yep.
As a structural isomers only should be considered, no stereoisomerism. All the isomeric alcohols with the molecular formula C5H12O are added separately to warm alkaline aqueous iodine. How many of these isomers give a yellow precipitate? First thing, alkaline iodoform test. Iodoform test is for this structure. And he's talking about alcohols. So iodoform test is only going to be true for this structure. We can ignore the ketone part, methyl with CHOH. Okay, that's where the iodoform test is going to be positive. So I've got 5 carbon atoms. So for the test to be positive, it should at least have this structure. So how many different isomeric alcohols can I make? I've got, how many carbons am I left with? This is 5 carbon atoms, right? So the remaining 3 carbon, so the remaining 3 carbon atoms could be in this manner, right? So what other ways can I arrange these 3 carbon atoms?
The last one on the first red one.
So, I mean, this is a must for the iodoform test, CH3CHOH. Now I've got 3 carbon atoms and I'm going to arrange them in a different manner, which is this, right? Is there any other?
Yep.
Is there any other possible way?
I don't think so.
No.
No. So it's going to be just 2. Okay, so remember, you weren't supposed to make all the alcohols. It would have been a lot easier if you just knew that this structure would be present and you can sort of rearrange the remaining stuff. And so we've got menthol is a naturally occurring alcohol, and menthol is heated with concentrated sulfuric acid. What happens when concentrated sulfuric acid is added? What happens to an alcohol?
Dehydrate.
Alkene.
It turns into an alkene. Okay? The OH is lost. And you'll get a double bond, and the double bond could either be on this side or it could be on either side. So what could be the structure of compound T? That's going to be, which one is the correct one? This one, right? TK, is that clear? D is correct.
So
What
why
they've-
that one?
What they've actually done is that we can get rid of the alcohol. These two molecules are exactly the same. They've just flipped it around. Right? Is that clear?
Right, okay.
Plus, the double bond is never going to be here. There's no double bond O. The double bond will not happen at the top. It's either going to happen over here or it's going to happen on this side. So this is the correct one. So this one, you've got a product is formed when 3-methyl pent 1,3,4-triol is heated and reflux with an excess of so pent, that's 5, 1, 2, 3, 4, and 5. 1,3,4-triol, 1. What is 3? 3 and 4. So you got OH groups over here. Triol, and you got a 3-methyl, which is on the third one, there is a carbon atom. So what, and it's getting oxidized by potassium. What will this turn into, this carbon?
Carbon dioxide. No.
Is this
Carboxylic acid?
Is
Carboxylic
this
acid.
aldehyde or carboxylic acid, right? But it's heated and reflux. Should it be an aldehyde or a carboxylic acid?
Carboxylic acid.
So this one is going to turn into a carboxylic acid. What about this one? What will this turn into? This is also an alcohol.
Ketone.
Ketone.
Nothing would happen to it. It's a tertiary alcohol.
Third degree.
It's a 3-degree alcohol. It's a tertiary alcohol. Tertiary alcohols do not get oxidized. This one will turn into a ketone. That's a secondary alcohol. Is this clear?
Yes, sir.
Yes.
So the final product is going to be this thing. And now the difficult part. Which one is this one?
A.
First one.
So starting with this carbon atom, COH, right? So you got COH, that's correct. Next carbon atom, that's CH2. This is also, it's going to have 2 H's, right? CH2. Then the third one, that's a carbon. So the third carbon, it's a carbon with a CH3 branch. You got a CH3 branch and you got an OH branch. So that's also true. And after that, it's CO. And after that, there is CH3. Everything matches. So that's A. A is correct. You've got which statement is correct? What's happening here? Which specific reaction is this? Halogenoalkane turning into alcohol. That's this one.
Nucleophilic substitution.
That's and you got NaOH aqueous and reflux, it will turn into an alcohol. And is this going to be SN1 or SN2? What is this? Primary or secondary or tertiary halogenoalkane?
SN2.
It's going to be SN2, so it's not going to be SN1. Remember, it's a primary halogenoalkane. Carbon has only one carbon branch, so it's this one. It's the OH ion will directly attack the carbon, and the Cl will get knocked out from the other side. So it's a one-step mechanism. Everything happens together. So that's an SN2 mechanism. So this one is SN2. So it's not elimination. It definitely is a hydrolysis. It's not a redox reaction. So this is, in other words, known as hydrolysis. It's an SN2 mechanism. It's a nucleophilic substitution mechanism. It's a structure. Now this one, structural and stereo, both will be considered. 2-bromopropane is heated with an excess of ethanolic sodium hydroxide. How many different hydrocarbons are produced? So I got a pentane, 5 carbon atoms, and on the second one, there's a bromine. What happens if I have ethanolic NaOH? What will this turn into? With ethanol,
Alcohol.
the ethanolic NaOH, remember,
Alkenes.
alkene, okay? Remember, aqueous NaOH turns it into an alcohol. But NaOH, which is ethanolic, will that's elimination. That's it will turn it into an alkene. So it's similar to dehydration. So you'll get a double bond at this point or at this point on either side. So how many products would be produced, including structural and stereo?
2.
3.
3.
Yes. So it's going to be 3. Basically, the double bond would, if the double bond is over here, that's going to be cis and trans.
Oh yeah, 3.
Okay, so that's 2 versions of this one. And if the double bond is over here, that's just 1. I mean, there's no cis trans. So there's 1 version over here, and there are 2 versions on this side. So it's going to be 3. Okay? Always remember, be very careful. Okay, whenever you've got alkenes forming, make sure to consider cis and trans as separate molecules. As many reactions take place in the engine catalytic converter, which pair of substances is produced both by the reaction in a car engine and in a catalytic converter?
Also,
Yes.
if the double bond is on the left side, why can't it be cis trans as well?
Because this carbon has 2 H's. So there is no other version. Like if you switch that around, it still remains the same thing.
Oh, okay. Yeah, sorry.
So previous one, what is produced both in the car engine and in the catalytic converter? It's B. Okay, because the car engine also produces carbon dioxide. What the catalytic converter does is that the unburnt or incomplete combustion carbon monoxide is also turned back into carbon dioxide. And the hydrocarbon, the unburnt hydrocarbons are also oxidized to produce carbon dioxide and H2O. So this one is B. So we've got this reaction.
Wait, sir. How is
Yes.
water produced in the engine?
Hmm?
How is water produced in the engine?
Hydrocarbon, you're burning hydrocarbons. Whenever you burn a hydrocarbon, what is produced? Water is produced.
Yeah, okay.
As a sample of L reactor with an excess of hot concentrate KMnO4. So which one out of these 4, hot concentrate KMnO4, will produce this thing when you oxidize it? Strong oxidation, hot concentrate KMnO4. What will happen to the I'll mark the double bonds first. So we'll one by one figure out the double bond is going to completely break, right?
Yep.
Just so that just a second. So anyway, so the double bond breaks in the middle, right? So that's the molecule breaks over here. So I've done that. So one by one, tell me.
B.
So what will this carbon turn into?
Ketone.
Okay, 2 carbon chains, that's a ketone. Okay, and 1 carbon chain, that's a carboxylic acid. So this one will turn into a ketone, and this one over here will turn into a carboxylic acid, right? What will this
Yes,
turn
sir.
into?
Carboxylic acid.
Okay, 1 carbon chain. This one also has 1 carbon chain, so they both turn into
Carboxylic
carboxylic.
acid.
And this one also turns into probably can't be B because over here you're getting 1 ketone and 3 carboxylic acids. Over here you've got 2 ketones, right? So it can't be B. Is that clear? What about
Yes,
what about what about this one? This is what? What will this turn into?
Ketone.
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 Okay, that turns into ketone, and this turns into what?
Carboxylic acid.
Carboxylic acid.
Okay, and this one also turns into ketone, right?
Yep.
Yes, sir.
Carboxylic
Acha,
acid. The last.
So, this is carbon dioxide.
Oh yeah, my bad.
No carbon chains. That's carbon dioxide and water, right? Anyway, so this molecule, is this the same as this? It has ketones, 2 ketones and 1 carboxylic acid. That part is matching. What about? So I would have to number this 1, 2, 3, 4, and on the 5th one there's a branch. So 1, 2, 3, 4. On the 5th one there's a branch. So up till carbon number 5, it kind of matches. What happens after 5? On the 6th one there's a ketone and then there's another carbon, right? So 6th and 7th, right? So you got 6th and 7th. That part is also matching. And on the other side, if I go to the other side, let's number that 8 and 9. Remember the numbering is, I'm just numbering it randomly. So this is 8 and this is 9. So that also matches. So both of them, they're exactly the same. Like if you start over here, 1, 2 is the same, 3 is a carbon chain, 4, 5th, there's a branch. So that's also the same. 6th one, 7th one, exactly same. If you move to the other side, that's the 8 and 9. That's exactly the same as well. Is that clear that this is going to be A? TK, clear?
Yes, sir.
Yes, sir.
As if here you got how many structural? Now again, you're limited to structural isomers. So C3H5Cl3, C3H5Cl3. How many do you have? I mean, you can try this on your own. Give me a number.
Five, maybe.
So, if you have 3 carbons, you can't really make a branch, right? So all I have to do is change the position of the Cl. So that's 3 Cls. What else? I can have 2 Cls and 1 Cl in the middle one. I can have 2 Cls at the end and 1 Cl at the other end. What else? I can have 1 Cl on each carbon atom.
Yeah. Right, sir.
And 2 Cls in the middle.
Because I can have 2 Cls in the middle and 1 on the right. So that's is there any other? I'm not sure if there is any other, but that's it. That's about it. The other ones would just be flipped versions of the same thing. Okay? There's no other, right?
No, sir. I don't
No,
think
sir.
So next is we've got ammonia and hydrazine are 2 compounds of nitrogen. Which statement are correct? Ammonia is this thing. It's NH3. And hydrazine is NH2 and NH2. So it's kind of the same thing. The N bond angle in NH2 is polar. Is this bond angle polar? The middle one. That's not polar.
non-polar, sir.
No. No polar.
I say NH3 and NH2 have lone pairs of electrons, but N2 does not. Do they have? Does this have lone pairs? Does this have lone pairs?
Yes.
Remember, N has 5 electrons,
Yes.
so only 3 are bonding. So, and I guess N2 also has lone pairs because 3 electrons shared, so 1
Yes,
lone pair
sir.
left. So that's also wrong. The oxidation number of each nitrogen in NH2 is +2. Is that +2?
No.
Yes.
It looks to be, okay, it's +1 into 4 hydrogens, and X times 2, the 2 nitrogens, the whole thing is 0. So X comes out to be -2.
-2.
Okay, so it's not +2. The reaction of nitrogen with hydrogen has a higher iteration.
Yes.
Okay, that is true. N triple bond is very strong. Achha, under standard conditions, which statement is correct? Cl2 can oxidize Br minus 1.
Yes.
Is Cl2 a good oxidizing agent or not? The Cl2 really like to
It is.
It is, right? So the top ones, I mean, the top elements are the ones. Cl2 has a very strong tendency to attract electrons. Br minus 1 is a bigger atom, so it likes to lose electrons. It's a reducing agent. So remember this in group 2. Sorry, not in group 2, group 17. You got Br2 and I2. The top ones really like to gain electrons. And when it comes to the ions, then the bottom ones are the ones that really like to lose electrons. So the top ones, the neutral elements, the top ones are the oxidizing agents. And when it comes to the ions, the bottom ones are the reducing agents. As a silver-nitrate is added to solution G, a precipitate is formed which does not dissolve when ammonia is added. What could be, which ion is he talking about? You add silver nitrate and a precipitate is formed and it does not dissolve.
Iodine.
So it could be iodine. It could also be bromide ions as well, because that dissolves in concentrated ammonia. Solid G is formed with sulfuric acid. A mixture of gases is formed, including hydrogen sulfide. What reaction is this one?
Iodine.
Sodium iodide.
That indicates a powerful reducing agent. That's iodide. You can remember, even bromide reduces the sulfuric acid. Is talking about this reaction. So this part, okay, when it comes to redox, Cl-1 does not like to lose electrons, but Br-1 likes to lose electrons. But Br-1 does not reduce the sulfur that much. Sulfur goes from +6 over here to just +4. But when it comes to I-1, you get a very powerful reducing agent. It really likes to lose electrons, and sulfur is forced to gain electrons. So sulfur gets reduced a lot. It gets reduced to sulfur or H2S, where its oxidation state is -2. So a lot stronger. It really likes to lose electrons. It's a lot stronger reducing agent. So that's the answer to this one, which is iodide. And as a 16 group 2 metals, they react vigorously with hydrochloric acid. Then N does. L reacts more vigorous. L is reacting more vigorously than N. So is L at the top of group 2 or at the bottom of group 2?
Bottom.
It's going to be, so N is at the top and L is probably at the bottom, because L reacts more vigorously. Bottom ones are more reactive. And MOH2 is more soluble than NOH2. So is M below N or above N?
M is below N.
Below.
So M is also below N, because hydroxide solubility increases down the group, right? You become more soluble when you move down the group. So the solubility increases. But we can't, they didn't give any comparison for L and M. So we can't really put where L and M are. So N would be at the top. That's one thing. So we'll just focus on that. So is calcium fine?
Yes.
Calcium is at the top, right? What's wrong over here? Because calcium is M. That's wrong. And that's the only option. Because in all other options, calcium should be at the top. So calcium is going to be N. So it's going to be B. TK, clear?
Yes, sir.
So we've got volume of oxygen placed under room conditions when 0.5 moles of calcium nitrate thermally decomposes. That's easy. You got calcium nitrate, it decomposes to form calcium oxide plus 2NO2 plus half O2. So the total, he's talking about the volume of oxygen. So 0.5 moles will produce how much? It's 1:half, right? So it's
0.25.
you get so 0.25 and you multiply by 24 dm cube, that's going to give you 6. Okay, we're getting 6.
Yes.
So M reacts with water to produce a colorless solution. A white precipitate is produced when its colorless solution is mixed with aqueous sulfuric acid. So it's reacting with water.
Barium sulfate.
Okay, so barium reacts with water. Barium is reactive, right? It will form barium hydroxide, which is also very soluble. Bottom ones, the hydroxide solubility is more. So you get a colorless solution. And a white precipitate is produced, which is barium sulfate. There's a pH3 element Q, it's reacted with oxygen compound R is formed, is added to water, the pH decreases. What could be the empirical formula of R? So he's talking about an acidic oxide. So which oxides are acidic? You got sulfur oxides and you got phosphorus oxides. So these are the oxides that are acidic. So which one is the correct answer?
C.
C.
It won't be C, it's going to be B. Because he's asking for the empirical formula. I mean, C is correct, but he's asking for the empirical formula.
All right.
Sir, what about Al2?
Oh, sir.
Yes, what's the question? The Al2O3, and they're not soluble in water. Like, where's the oxides?
Okay.
The first two are basic. Yes, what's that? Yes.
Yeah, no, I wanted to ask if you could explain 15 again because I don't get it.
Just 1 second. So remember, the first two oxides are basic. MgO is less basic. Al2O3 and SiO2, they don't dissolve in water. They have no reaction. Then you have phosphorus oxides and sulfur oxides. These are acidic. They would form an acid when you put it in water. So these are acidic. The 15 karna dobara.
Yes.
15 was easy. That calcium nitrate was decomposing. So this is the equation for calcium nitrate decomposing. And they gave you 0.5 moles of calcium nitrate. So 0.5 moles will produce 0.25, right? It's 1:half.
Yes, sir.
So you got 0.25 moles of oxygen being produced. How do you figure out the volume of a gas? That's moles into 24 dm cube. So that will give you 6 dm cube. Okay?
Oh, okay. Yes, thank you.
So we've got this reaction. X, Y, and Z are elements in period 3. The results of some experiments carried out with compounds of these elements are shown. Results of adding the oxide of the element to water. So forms acid, right? So which oxide forms acid? It's phosphorus and sulfur, right?
Yes.
Then you got no reaction. No reaction. Who has no reaction? It's aluminium and silicon, right? And which ones they form hydroxides? That's probably sodium and magnesium, right? Anyways, next one. The chloride only dissolves. So whose chloride only dissolves in period 3?
Sodium.
Okay, so it's sodium, right? It's no, NaCl is the only one that dissolves. NgCl2 is also mostly dissolving, just a very slight hydrolysis. And when you go down the group, it's just hydrolysis. So this one is definitely, Y is definitely sodium. So Y is why is sodium? So we're looking at either B or D. The chloride hydrolyzes with water, so that it does happen. Aluminium chloride and silicon chlorides, they do hydrolyze, so I can't really figure out whether this is aluminium or silicon. And phosphorus and sulfur chlorides, they also hydrolyze. Resulting of adding, so the reacting with the HCl, right? So forms a salt. Na sodium oxides, they're basic, so they would form a salt. And aluminum oxide would also form a salt. Right? This also that if you go down the group, sodium oxides, magnesium oxides, they would form a salt with HCl because they're basic. Aluminum oxide will also do that. These ones will not, they're acidic oxides, so they won't form a salt. So yahan pe there is, you've got these two options, but this is definitely wrong. Z can't be Al. The first one is correct, B is correct. Because X could be silicon. Is that clear?
मेरा आंसर A है.
So then X is silicon oxide. So let's look at A first. X is Al. Okay, that fits the description. That works out. Silicon oxide with HCl, just a second. Oh, silicon oxide is acidic. Okay, so that is wrong. Silicon oxide will not react with Na with HCl. It will react with, it's an acidic oxide. Okay, that is what is wrong with this one. X can't be silicon. Okay, is that clear?
Yes.
Okay, it won't form a salt with HCl. It will form a salt with NaOH, but not with HCl. Silicon oxide is acidic. So the first one is definitely aluminium then. So this part is wrong. I said X is aluminium. That's confirmed. So this was wrong. And Y is Mg. So we had two options, right? So they assumed this thing. This is where we got things wrong. They said result of adding the chloride of the element to water, it dissolves. So which is why we ended up removing Mg actually, but they actually kept Mg because Mg has very slight hydrolysis. It mostly dissolves. So they actually took it as dissolved. Okay, this is where we went wrong. That we just assumed that Mg also mostly dissolves. There's very slight hydrolysis. So which is why, anyways, B can't be true because it's definitely not silicon. Okay? But is this clear? This one. You clear? Is this clear?
Yes, sir.
As the next one, we've got this reaction. What is the concentration of silver ions in equilibrium when copper ions is 0.1? As remember, copper is added to a solution of silver ions. So these two are initially added. Now that means both these ions will be produced in equal quantity, right? So this is going to be X and this is going to be 2X. I mean, the moles are different. So these two are reacting. And he's saying that the concentration, what is the expression for Kc in this case? It's going to be copper ion concentration, and that's going to be power 1 divided by silver ion concentration, and that's going to be squared, right? The solids are not written in the expression. And the value of this thing is 1 times 10 power minus 10 power 5, right? And they gave us the copper ion concentration at equilibrium. So that's already given. That's 0.1. So silver ion concentration can be found out. So what are we getting for this? Do you remember, you don't have to make any tables because they already gave the concentration at equilibrium. ऐसे क्या बना? Did anyone try?
C, sir.
C.
Did you take the under root as well, right? So this one, we've got acetamide potassium magnate 7 reacts with ethane diode. The reaction takes place as shown. How many moles of iron 2 ethane diode reacts with 1 mole of potassium magnate 7? So how many moles of iron 2 ethane diode? That's the first thing. This thing is one thing. So I'm going to take this as one thing. So this is what is the formula of this? Iron 2 ethane diode. That's ethane diode. That's FeC2O4, right? And together they produce what? They produce Fe3 plus. They produce 2 CO2, and they give off 3 electrons, right? So I've basically combined these two equations. Okay, this is one thing, right? FeC2O4. Is this clear? So this thing is combined is producing 3 electrons. You clear? That's
Yes,
my
sir.
Yes.
oxidation. Achha, that's my oxidation equation. That's my reduction equation. So the electrons gain and loss, they got to be equal. So 5 electrons, 3 electrons. What do I multiply this by? And what do I multiply this by?
3 and 5.
Okay, so I'll multiply this, the above one by 3. This will become 24H plus 1. This will become 15 electrons. This will become 3Mn2 plus. This will become 12 water molecules. And I'll multiply this by 5, right? So it's going to be 5 of this, 10 of this, and 15 of these. So anyways, the electrons gained and lost are equal. And he's saying, okay, what's the ratio of potassium magnate to C2O4? So the ratio is, what is the ratio? It's 5. I mean, this is 5. And potassium magnate is 3, right? So it's 5:3, right? So if this is 1, what will this be?
5/3.
Okay, that would be 5/3. What is 5/3? That's B, right?
1.67. Yeah.
5/3 is 1.67. So the ratio that I'm getting is 5 ratio. I mean, if this is 3, this should be 5. So it's 5:3. And that would boil down to 1:1.67. Okay, so we're getting D. Clear? Number 10.
Yes, sir.
That's the next one. We've got XeF6 plus CH2 of this reaction. All substances. Which statement describes the standard enthalpy change of reaction for this reaction? The enthalpy change when a total of 1 mole of products is produced. Which the standard enthalpy change of reaction for this reaction? The enthalpy change when a total of 1 mole of products is produced. I don't think we're getting 1 mole of products, right? The enthalpy change when a total of 1 mole of reactants is reacted, be reacting 4 moles. The enthalpy change when 1 mole of water reacts.
3 moles are reacted.
Yeah, it's 3 moles, right? When the enthalpy change when 6 moles of HF are produced. That's right. The other statements are all wrong because it's not 1 mole of water that's reacting. It's not 1 mole of reactants that are reacting. It's not 1 mole of products that are getting produced. You got 7 moles of products, right? So it's definitely D. This one, we've got this reaction. Which expression gives the standard enthalpy change of formation of methanol? So what is the equation of the formation of methanol? That's carbon and hydrogen and oxygen reacting together to form methanol, which is CH3 and OH and half of this and 2 times this, right? So what is the data that's given? I'm given the data of combustion, right? The combustion of carbon that's given. Combustion of hydrogen is also given. The combustion of oxygen is already 0. Combustion of methanol is given. So what is the formula that I'm going to use?
Reactants
Reactants minus products.
It's going to be reactant minus product. So reactants are these. So what are my reactants? That's C, that's C94. 2 H2s, that's minus 2 to 86 times 2. And minus the products. So there's only one product, which is minus 726. So the answer is
C.
which? You get C. Which structures are giant molecular out of the three?
P and Q.
Okay, remember this is not giant.
It has
P and
60,
Q.
right?
Variable, but usually there's one which has only 60. But it has a fixed number of atoms. Sometimes it has 60, sometimes it has 72, TK. But the number is fixed. यहाँ पे the sheets can be as big as possible. The diamond structure could be as big as possible. So P and Q only. As I got a sample of gas, how many moles of gas are present in the samples? That's moles is what? Pressure, that's 100. Volume, that's should be in meter cube. So cm cube to meter cube, that's PV over RT, that's 8.31 times temperature, which should be in Kelvin. So 37 is what? What is 37? That's 310.
Yes, 310.
So what do we get for this?
9.31 into 10 raised to power minus 3. It's basically 316. So
Okay, so just remember, make sure the units are right. Meter cube, Kelvins, pascals. I got this one. Which one? What is this angle?
120.
120.
Okay, number one is 120. What is the second one? This one.
109.5. Sorry, 107.
107.
Okay, because there's one lone pair, 3 bonds. So that's so it's B. The last one is tetrahedral. That's 109.5. In which pair do the species have different shapes from each other? What is the shape of BCl2 and CO2?
Linear.
Okay, both of them are linear because there are no lone pairs. Okay, C is CO2 only 2 pairs of bonds, and CH4 and NH4 they're both tetrahedral. What is NH3? NH3 is pyramidal because there's a lone pair. So it's like a fan whose blades are pointing downwards.
Trigonal planar.
That's trigonal pyramidal. BF3 is planar
Right.
because boron is in group 3, so it doesn't have lone pairs. The last two have the same shape as well.
Bend.
Okay, that's bent. So which statement about 3p orbital is correct? It can hold a maximum of 6 electrons.
Yes.
Yes.
He's talking about the orbital, not the subshell. The orbital can have a maximum of 2 electrons. The orbital can have a maximum of just 2 electrons. The 3p subshell has 3 orbitals. And each orbital can have a maximum of?
Oh, right.
So over here, he's talking about the orbital, not the whole subshell. So the first statement is not true. It has the highest energy of the orbitals with principal quantum number 3. Third shell में क्या होता है? You got 3s, you got 3p.
3D,
you also-
3D as well.
3d as well. So that's an even higher energy compared to 3p. It is at a higher energy level than a 3s, but has the same shape. It obviously has a
No.
different. It is occupied by 1 electron in a isolated phosphorus atom.
Yes.
Okay, because phosphorus is group 15, group 5. So it's going to be P3. If it's P3, then there's going to be 1 electron in each orbital, right? So D is correct. I'd say there's another moles. 3.7 grams of this is added to. Now this is, I'm guessing, a limiting excess question. It's copper carbonate with HCl, and it will form copper chloride. Plus water plus carbon dioxide. So you got this thing. So 3.7 grams. How many moles is this? Tell me the moles of copper carbonate and separately tell me the moles of hydrochloric acid.
For hydrochloric, it's 0.05.
So you got 0.05 moles of this. What's got here? 3.7 grams of copper 2 carbonate. So take copper as 3.5.
Zero 0.029.
Now this one is 0.029 moles. So which one out of the two is in excess?
The hydrochloric acid.
No, it's copper carbonate that's in excess. Because 0.05, it's 2:1, right? So 0.05
Right.
will react with how much? It will only react with 0.025, right?
0.025.
Okay, that's the one in excess. Not all of it is going to react. Only 0.025 will react. Okay, the easy way to figure out which one is in excess is, remember the larger one is not always the one that's in excess. It should be more than the required amount. The easy way to figure this out is take 0.05, divide that by 2, take 0.029, divide it by its ratio, which is 1. Whichever number comes out to be bigger, that's the one that's in excess. So 0.029 divided by 1 is bigger compared to 0.05 divided by 2. So that means this is excess. You don't use the excess moles. Don't do any calculation using this. So if you want to figure out the volume of carbon dioxide, you'll use the limiting reactant, which is HCl. So it's 2:1, right? It's going to be, this should be 0.025 moles, right? And you multiply it by 24.
0.6.
So it's going to be A. You can just make sure that if in a reaction, you're given the moles of two reactants separately, then you would have to always check whether it's which one is the limiting, because you're going to use the limiting reactant moles. Never use these moles. So well, we've got this one. What is the correct distribution at a higher temperature T2? At a higher temperature.
B.
Yeah, B looks fine. It rises over here, drops on this side. It becomes flatter as well. So the B is fine, I guess. So it has to be flatter as well at a higher temperature. So, okay, we're done. Do your questions?
No, sir.
Let's continue tomorrow then.
Assalamu alaikum. Have a nice day.
Yes, sir.
Okay, sir. Allah Hafiz.
Yes.